Hello everyone. At the last lecture we discussing about the reaction involving the CO bond. One more reaction is remaining from that part. That means reaction with the hot concentrated acids. The reaction of the different alkyl ethers with the acids. For example, if we are taking an example of our hydrochloric acid. Now, if we are taking here hydrogen iodide or a hydrogen bromide or hydrogen chloride, hydrochloric acid. Now, from that iodide is more reactive as compared to these two. Due to that reactivity, we are taking a reaction of from these acids, from these acids with our ethers. We see the reaction here. Plus, if we are taking HX, that means from these, anyone, for this X, we are taking iodide or bromide or chloride. Now here, from this reaction, we are getting the main product. First product is our alcohol, R-OH, plus this R is react with this X, that means RH. If we are taking an example of dimethyl ether, CH3O dash CH3 plus H, if we are taking iodide, then this H is attaching to this place, that means CH3OH, our methyl alcohol is prepared here, and this I is attaching to that one CH3 plus CH3 methyl iodide will be produces. From this reaction. Now, if we are taking the reactivity order, it is our reactivity order. That hydrochloric acid HCl is very less reactive in the with the ethers. Now, another, if we are taking the aryl ether or aryl alkyl ether. Here also we are taking an example of this HI, that means it's a more reactivity between. If we are taking the aryl alkyl ether, then that aryl alkyl ether have the strong and a very short bond between the oxygen as well as the aromatic ring. If we are taking an example of anisole, you know the structure of that anisole, that means this aromatic ring is present, the bond of oxygen is present here, and a CH3, it's our anisole. Now, from that anisole, the bond between this O and this aromatic ring is a very short, but it is a very strong bond. Hence, this aryl alkyl ether, when undergoes the cleavage of the oxygen, the alkyl halide and that alkyl bond is breaking from this O, and the hydrogen from this is attaching to that one place, and here we are getting a phenol. When we draw the reaction, complete reaction, then you understand HI. Now what happened? It's a very short but a strong bond. That H is attaching to that of O. see here. That O, and this hydrogen is attaching to that of a O. Phenol will be produces, and this CH3 is attaching to our iodine, CH3I. That means nickel iodide is produces. Now from the aryl alkyl ether we are getting a phenol. And if we are taking an alkyl ethers, then we are getting the alcohol. Now it's our reaction of the hot concentrated acids. Now the next one reaction is electrophilic substitution reaction. Now the next one will be the electrophilic substitution in the aromatic compounds into the aromatic ethers we see here. Aromatic ethers, or we says that the aryl alkyl ethers. Now here the electrophilic substitution will be happens into the aromatic ethers. Now into these alkyl groups, the aromatic ethers having the ring activity or ortho para detection. The alkyl group into the aromatic ether is in a ring activity, the ortho as well as the para direction the group towards the electrophilic aromatic substitution. This we see by the resonance structure. Now this O having the lone pairs, two lone pairs are present on that of oxygen. What happen here? One lone pair will be goes here and it forms a double bond. And from this double bond, one electron will be goes here and it have the negative charge. That one lone pair is goes out. So the positive charge increases on that of oxygen. Now into the next one, what happen? This electron is goes towards this and it form a double bond. These all you are studied into the resonance structures. Now what happen? This double bond also goes here. It forms the negative charge. That negative charge goes here. It form a double bond. Now this one is goes here. Double bond will be formed here. Now here negative charge will be produces and that negative charge is goes on this place and it forms a double bond, and this bond is goes again towards that of oxygen. So our main structure is getting at a last, that means after the resonance of this aromatic ether. It's our electrophilic substitution. Now that positive R effect of that OR group, our this OR group results in increased electron density at the para and two ortho position. If we are taking the numbering here, first, second, third, fourth and a fifth one. Now from that, if we are taking the structures of the second, third as well as the fourth one, from these at the ortho and the para position, two ortho positions and one para position, we see the resonance. Now the next one reaction is the halostation reaction. Here we are taking an example of anisole. That anisole is undergoes the bromination with the bromine in the acetic acid. We are taking an example of anisole here. Then the benzene ring from that group, from that anisole is produces, but that position of the bromine is different. Therefore, we are getting two products. First will be the para-bromo anisole and the second will be the ortho-bromo anisole. There is percentage. One will be the major product and other will be the minor product. If we draw the reaction, then you understand. Here we are taking an anisole. CH3. The benzene ring is present here. And our alkyl derivative, that means methyl, is attaching that anisole. Now that anisole is undergoes the process of bromination with our acetic acid. Now there are two products will be produces. That Br is attaching to the para as well as the ortho position. First, this bromine group is attaching here first. That means P bromo anisole. And the second is our minor product. That means from this reaction the para-bromo anisole is produces 90% and this ortho-bromo anisole is produces up to 10%. Only 10% we are getting the ortho. Don't forget that. Ortho-bromo anisole. That ortho-bromo anisole will be produces in the second part or a second one. Now it's our halogenation reaction. Now the next will be the reaction of Friedel-Crafts reaction. It's a most important reaction, our Friedel-Crafts reaction. The next one will be the reaction is our Friedel-Crafts reaction. It is also most important reaction. Now, into the Friedel-Crafts reaction, when if anisole is react with, there are two reactions we discussing here. First will be the if anisole is react with alkyl halide, and the second one is the anisole is react with acyl chloride in the presence of anhydrous aluminium trichloride, that means our Lewis acid, as a catalyst. Then we are getting the two minor as well as the major product. First we are discussing about the alkyl halide or alkyl chloride. Here we are taking that methyl chloride anisole. Is react with first alkyl halide. We are taking the methyl chloride. presence of AlCl3. Now we are getting the toluene will be produces in this reaction. Methoxytoluene will be produces in this reaction. It's our major product. OCH3. First will be the para. At a para position, that a CH3 is attaching. So we write the places. 1, 2, 3. At the fourth places, this CH3 is attaching. Here we write 4 methoxytoluene. And the second one, minor product. There are two products will be produces. First will be the 4-methoxytoluene, and the second one is the position of the CH3 group is changes. OCH3 as it is. That the second place CH3 is attaching first and second. Therefore, we write as a 2-methoxy. Our remaining part is our toluene. It's a major part. It's a minor part. Now, these are two products are produces from these anisole. The second one reaction, that means by the acyl chloride. We are taking here that anisole is react with acyl chloride. Then we are getting the methoxyacetophenol. See here what we are getting. Our anisole is again react with. Here we are taking an example of acyl chloride. CH3 COCl. CH3 COCl. It's also in the presence of alkyl chloride. We are getting two products, that means our methoxy. Yes, we are getting the methoxy CH3 CO. That group is attaching that part. Our methoxyacetophenol. We are getting methoxyacetophenol. But at the fourth one place, 1, 2, 3, 4, fourth place, that methoxyacetophenol is attaching, and the second product is produces from these is at the second place. Our this COCH3 is attaching. OCH. That means 2 methoxyacetophenol will be produces from the, again we write a major product 4-methoxyacetophenate, and the second product is a very small quantity we are getting, so we write the minor product 2-methoxyacetophenol. Now it's the our Friedrich-Crafts reaction, very important reaction. It is asking in your exam also. Now the next will be the nitration reaction, when that anisole is react with the concentrated nitric acid. Here we are taking the concentrated nitric acid in the presence of concentrated sulfuric acid. That nitric acid is react, but in the presence of our sulfuric acid H2SO4 into the presence of concentrated sulfuric acid, then we are getting the ortho-nitrophenol as well as the para-nitroanisole. Ortho-nitroanisole as well as the ortho-nitroanisole. Para-nitroanisole. We write the reaction here. Our anisole is react with concentrated nitric acid HNO3. It cannot be takes place directly react with that anisole. That only NO2 is the react from this. Also we are using the concentrated H2SO4. Now there are two products also produces from this reaction. First will be the position we write here nitroanisole, or the second there are two products will be produces. First will be nitroanisole and second will be the para-nitroanisole. One, two, three, fourth position. Our nitro group is attaching. Therefore, 4-nitro anisole. It's our major product. Plus, only the nitro group position will be changes at the second place that nitro group is attaching. Therefore, 2-nitro anisole, it's a very minor product. It's the major product. Now, these are the different reactions of the ethers. Now, the last one point from this topic is uses of alcohol, uses of phenol and uses of ether. Now first we see the uses of alcohol. Alcohol is used as a solvant into the paint and the vernishing. Into the paint, that alcohol is used to as a solvant. Now if we are taking the ethyl alcohol, that ethyl alcohol is used as an anti-freezing agent into the automobile radiation. That ethyl alcohol is used into the anti-freezing agent into the automobile radiations. Now in these days the alcohol is used to making an sanitizers. Now that's also use of alcohol. The second is our phenol. That a phenol is used for preparation of the phenol formaldehyde resin like a bakelite. That phenol are used as antiseptics. That also used into the making of the mouth fresheners or different deos or different our sprays. Now the last one is uses of the ether. Into the surgical operation, if we want to unconscious that patient, then that ether is used at the ancestry into our surgical operations. That dimethyl ether is used as a solvant into the different reagents like Grignard reagents or into the fats, waxes or oils. Now these are the uses of ether. Now by using uses of alcohol, by uses of phenol, by uses of this ether, we completed our chapter alcohol, phenol and ether. Thank you.